starting, and in the previous class we got the introduction regarding the transistor. Transistor is two junction, three terminal device where three terminals are emitter, base and collector. And we have two kinds of transistors. Those are NPN transistor and PNP transistor. In the NPN transistor, the majority charge carriers are the electrons, and PNP transistor, majority charge carriers are both. And we have also studied what do you mean by emitter, what do you mean by base, and what do you mean by collector. So today we will study how can we connect the transistor with the external battery. This is called, you can say, action of transistor. Action of transistor. First we will connect the NPN transistor. We will see how it behaves, what is the direction of current, how it behaves, and how well we connect this one with the battery. We shall see. First, NPN transistor. NPN transistor means P region is sandwiched between two N regions. So how can we connect with the battery? Is we first draw the block diagram of the connection. So block diagram means first we will draw the NPN transistor where emitter is smaller compared to the collector. So this is what the emitter is, and this is what the base is, and this is what the collector is. Now I am marking this is N and this is P and this is N. So and while connecting, you just remember one point. Whatever the transistor it may be, the NPN transistor or PNP transistor, whatever the transistor may be, you have to remember one point. See, I told you this junction is emitter base junction. So always remember, emitter base junction must be in forward bias. And collector base junction is in reverse bias. So this is what the connection is. You have to always connect in this fashion. If it is emitter base junction, that should be in the forward bias condition. If the collector base junction, that should be in the reverse bias condition. So let us see how can we connect the NPN junction. So this half of the transistor must be in forward bias, and this half of the transistor must be in reverse bias. So if it is in forward bias means, I am drawing and just letting a gap for the battery. Now here N type will be there. N type semiconductor is there. Means N type for the forward bias. Here what terminal should be connected? Can you tell me? Okay. So N type semiconductor must be connected to negative terminal of the battery, and P type must be connected to the positive terminal of the battery. So it is positive and this is negative. Now this section becomes the forward bias condition. Similarly, this half, or you can say collector base junction, must be in the reverse bias. And this is N means, I am writing C here. This is N means, I am just letting gap for the battery. Can you tell me which terminal must be connected for the reverse bias? Being this is N, if it is in a reverse bias means negative must be connected to the positive terminal of the battery. So here it must be connected to positive terminal of the battery, and P must be connected to the negative terminal of the battery. So this is the positive E and this is the negative E's, right? So this is what the connection. So here potential applied is V, I am just writing here, VEB, and whatever the potential applied here is VCB. VC, voltage across the junction, collector base junction, and voltage across the emitter base junction. So this is what the connection for, or you can say the block diagram for the NPN transistor. This is the connection. And the direction of current, how the current is flow and all, we shall discuss. So hope you just note it down first. This is, that is, emitter base junction is forward bias condition. I am just suggesting here itself, writing here itself. This always must be forward. Simply I write this short form. It is FB forward bias, and it is RB reverse bias condition. So this must be in the reverse bias condition. This must be in the forward bias condition. So let us discuss regarding how it works and how the charges are flow. What is the direction of current? So first, as we know, here in the N terminal, or you can say N region, majority charge carriers are electrons. There are so many electrons will be there. I know so many electrons will be there. And here in the P region, small number of holes will be there. And in the N region, moderate number of electrons will be there. Right. So this is what the doping is. Side emitter region, highly doped, collector region, moderate doped, and base region is lightly doped. Now, here electrons are majority charge carrier, and this N is connected to negative terminal of the battery. If it is connected to the negative terminal of the battery, these electrons get repelled by the negative terminal of the battery. And these electrons get repelled by negative terminal of the battery and start moving in the N region. These electrons start moving in N region from this end to the base end. They start moving from this end to the base end. If the electrons are moving, means they induces a electric current. So electrons are moving from here to here, right? So if the electrons are moving from here to here, means current starts flowing like positive to negative terminal. So positive to negative terminal means electrons are moving, electrons are moving in this direction. Electrons are moving in this direction means current is flowing through this, right? And this current caused by movement of the electron in the emitter region. Movement of the electron in the emitter region. Hence, this current is called as emitter current. Emitter current. So emitter current comes when majority charge carriers, or I will simply write electrons, get repelled by negative terminal of battery. Just writing short form, constitute a emitter current, shortly known as IE, emitter current. Now, so come back to the figure. As these electron moves to the P region, it is going to the P region. There are, in the P region, holes are there. P region, majority charge carriers are the holes, and those holes absorbs the electron, but number of holes is very less because it is very lightly doped. Number of holes are very less, so very few number of electrons get absorbed by the holes present in the P region. So what is happening when electron moves from N region to P region? Very few electrons get absorbed by the charge carriers present in the P. So by moving this electron to the base region, the base current is formed as electron moves from emitter to base, constitute base current. So remember here very few electrons. If 100 electrons are come to the base region, only 5% of electrons get absorbed. Only 5% of electrons get absorbed, and remaining 95% of electrons start moving towards N region once again. So here electrons are repelled and holes get absorbed, and here you can say conventional direction of the current is in this direction. I B from positive to negative. So it is what? The base current, constituting the base current, which is driven by I. Right? So now here only 5% of electrons are get absorbed. Remaining 95% of electron enters into the collector region, where also so many electrons are there. Now you can see all the electrons are collecting here, and emitter region emitting the electrons, those are first absorbed here, and remaining electrons are collected here. So it is called as a collector, and so it is called as the emitter, and this is what? The base. Now, as soon as these electrons, 95% of electron reaching the N region, and this N region, or you can say this collector region, once again connected to the positive terminal, these electrons start moving to the positive terminal. Now electrons are moving like this. And you can say the direction of current is opposite to the movement of electron, and it is collector current. It is what the collector current is. So you can say here the current which constitute by the collector current, base region is a base current, and emitter region is a emitter current. So that is regarding the collector region. As the electrons, I am not writing all of that theory part. So electron enters to the N region, and collector being connected to positive of second battery, or battery, I will write battery. These electrons moves to the battery constitute the collector current, that is IC. Collector current, that is IC. So this is what regarding the action of NPN transistor. Whatever the transistor may be, first you have to remember emitter base junction must be in the forward bias condition, and collector base junction in the reverse bias condition. So this junction is the forward bias condition, and this junction is the reverse bias condition. So we have connected like this, and let me recall what we have explained here. So first, this N region is connected to the negative terminal of the battery. These electrons are get repelled, so start moving in this region. That constitutes the emitter current. So as emitter current comes and still it is connected to the negative terminal, the repulsion is more. Hence the electrons start entering to the P region. In the P region, majority charge carriers are the hole, or you can say in the base, majority charge carriers are the hole. So some of the electrons, only 5% of the electrons get absorbed by these holes. Remaining 95% of the electrons moves towards the collector region. As here also you can see the movement of electron that constitute the base current IB. And furthermore, still it is negative field is applied here. Those electrons get attracted by the positive. Here, number of electrons are collecting. Those are attracted by the positive, and movement of the electron takes place, and that movement constitutes the current that is called the collector current. And here at this junction you can write, IE is coming towards here, and it is get divided into two currents. Emitter current is divided into two currents, that is IB and IC. So I can write IE is equals to IB plus IC. You always remember base current is very smaller compared to the collector current. Why? Because here number of charge carriers are very less, very few. Dopant, the number of dopant, or you can say doping, is very less. Hence, the current for the current for the base is very less. And this diagram we can also show by the symbol diagram also. If I take this symbol, this is what the transistor. This is what the transistor is. Just making it as a circle. And this is what the base is, and one of them is an emitter. So it is NPN transistor. It is P. This is 1N and this is 1N. So I am showing the direction arrow mark here means it becomes emitter and it becomes collector. So emitter is connected to the negative terminal of the battery, and positive terminal of the same battery is connected to the base signal. So this is emitter and this is base, and this N region being reverse bias, it must be connected in a negative terminal. So it is a positive terminal and negative, positive and negative. It is connected here. And the direction of current you can see it is IE, here it is IB, and here it is IC. So this is what the symbolical representation of NPN transistor in action. So this is what the NPN transistor is in action. NPN transistor or any transistor in action means how can we apply the voltage and what will be the direction of the current. What is taking place here? That is what the symbol is. So let me tell one more thing here. As this is in forward bias condition, these two are in a forward bias condition. Here one junction will be there. That is, here one, I can say a depletion region is there. Being forward bias condition, this depletion region go on reducing. As the depletion region go on reducing means here whatever the resistance will be there in this region, whatever the resistance will be there, that is getting reduced. So being this junction or this depletion region is connected in reverse bias, here the depletion region go on increasing. If the depletion region go on increasing means here the resistance in this region resistance is increases. And here resistance is decreases. Remember these 2 points also. It depends upon the size of the depletion region. So just make the notes as per I have given and follow the notes what we have given to you. Those are very important. Make these notes as your target point and write your own notes by referring the hard copies given by the college. So just take a screenshot and make the notes.